All right, everyone, I am back, and here you can see that I've done a little bit of shuffling or pin swapping of some of the signals. So row 0 is where it was, and then most of the columns and rows have shifted. However, going down from pins 3 to 18, it's more or less still in order. So column 13, 14, 12, 11, 10, all the way down to column 0, and then we have the rows down here. So here's what it looks like after I resync to the databases. And again, that was simply done by selecting ECO update PCB. All of the changes were brought back in from the schematic. And now you can see how simple this really should be to lay out, because there is no crisscrossing of signals. And we can really leverage software to make our hardware or our layout jobs easier. So let's go ahead and finish up with the routing here really quickly. One thing I'm already noticing is we might have to move some of these decoupling capacitors, just because getting all of these signals out in this tight space is going to be quite painful. So yeah, let's just go ahead and get started. If we need to move things around, so be it. Not a huge deal. And yeah, we'll go from there. Alrighty, so I'm actually very happy with how this turned out. You can see that there's maybe some small little fixes that we need to do. I can already see that we might need to make this region a little bigger here and allow this trace a little bit more space. What do we have here? Yeah, line to line spacing. It's not liking that too much. But wow, look at this. Very, very clean. We're able to add in a decent amount of space. We don't have to worry about dropping a ton of vias. And in general, let's turn on smoothing here. In general, not going to have to do a lot of cleanup after the fact, as usually what I try to do is remove, like if there's a lot of these corners that are redundant, I'll try to remove those. But again, I'm not seeing a lot of that right now because we were able to do the pin swapping. We've made our job much, much easier in general. So, looks like I missed two connections here. Let's do those really quick. So these need to go over here. We'll do that on the bottom layer. And yeah, this goes over here. Let's keep with this nice little organization that we have here. And we can remove this trace. And this trace. And this trace here, we need to connect right next to it. And we've got plenty of space. There we go. Now the only thing we should have to do is to drop a via for this power net here, and everything else should just kind of sort itself out. There we go. There we go. All right, so this needs a via. Perfect. We're going to slide this a little bit. Of course, the moment I say everything's perfect, we start getting some trouble. There we go. Close enough. What we can do is probably even move this via just a little bit in. That'll give us more space for this routing. Perfect. Okay. This net here is going to get a via shortly. Let's add some of these ground vias. Let's use the same structure that we used here. So this and this, copy on this pin, and drop it on these ground pins. We might as well do it for all of our decoupling capacitors at this point, and even power pins when we can. Oops. Lots of grounds here. Ground, 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 ground. Okay. Now what I want to do is scooch this guy over a little bit, because we do need to be able to drop a power pin. And we can slide, you know what, let's just go ahead and delete this via and repaste it since we already have it in our buffer. Perfect. And we just want to add a via right over here. That's going to be our one. Oh, actually, you know what? We do not need that. The 1.1 volt net is actually an internal regulator net. And these are just providing bypass capacitance for that internal regulator. So really, it does not need to have a... Well, you know what? We should connect them together internally. Never mind. So let's just do that just in case. Deselect everything here. Yeah, so let's add that via. Let's just go ahead and connect these just in case for some reason they're not connected internally. But really they should be. Yeah, we can move these.
Do the move command. Should be sliding edge. Maybe if we just do one at a time. Nope. Okay. Just enough so that we can stick a via in there. And you can reroute these back together. And these will get a via here. And this will get a via on the side here. Perfect. And yeah, we should move this as well. Turn these off so we don't accidentally select a net. Move command. Perfect. There we go. We can move this guy a little bit. Not that big of a deal, as this is just a pull-up. These can connect together. Hopefully not like that. There we go. I just like to clean things up a little bit sometimes. Perfect. So this will need 3.3 volts, although space is a little limited here. What I think I can do is if I move this just a tad. Nope, not enough space here probably. You know what? We'll just drop the via here. I personally prefer when possible to have my vias sort of behind the decoupling capacitor, if that makes sense. It's not that this won't work. It's just kind of the best practice that I was taught. So you can kind of think of the current going, you know, from the via through the capacitor and then to the power pin rather than kind of splitting. But I might just be making up things up here. That's just what I was taught when I was learning. We have plenty of analysis tools at our disposal in the Cadence suite to verify if our decoupling is good or not based on this strategy. So I'm sure for this case, it'll be more than sufficient. And what I'm thinking is we slide these guys over just a tad. Move this guy to this side. And then this will get a V right there. Perfect. It is always nice when everything just kind of comes together, you know? You can start to see the full picture. So show our connections here. Let's go to our save our design, go to our summary. We have 30 unrouted nets left. A couple of them are power nets. Yeah, so these are just saying that they want to be routed together. But in terms of total connections, or these rats that we see, we have 69 left. So very, very close to completion. All right. Let's see what else we need to do here. Let's go ahead and route these signals to the flash memory. Make sure that we have enough space. Might be needing to drop vias a couple times here, just in case. But for now, if we don't need to, we won't. I can already see we're going to need to give it just a little bit more room. Perfect. And then this we can slide up and to the side. And we have, what is it, 4 connections that we need to be able to route out of here. Might be a little tight, but we'll try to make it work. So there's one. Let's at least get it out a little bit too. Come on. Well, already having trouble. Okay. So let's see what we can do here. This we said we would fix later, so let's just not worry about that right now. We can give this net a little bit more space. And this is pretty much as far as it can go without going completely 90-degree. And it looks like we're just going to have to try to make space for one more connection here. I think we should be able to do that. So we slide this over. Oh, that's getting ugly. Let's delete some of these. So we know that these have to pretty much go directly straight up. This we can slide in a little closer. Actually, it's better for these to be coupled as closely together as possible anyways. So we can go ahead and just fix that routing a little bit. Yeah, this seems good. So this net here, where we can, we want to route as close as we can to this power net here, and then come down to these nets. And we'll worry about fixing this in a little bit. At least we know that we have enough space here. So you know what? Let's try to route it now. Perfect. So now this 1.1 volt net, we have plenty of space to route off to the side. And we can lift this QSPI SD3 net out. Perfect. So now we can route this. Come on. There we go. Now we can route this out of this tight little area here. Actually, we can even slide these a little bit and give them a little bit more space, as we were able to reclaim sort of this area from these power nets. And I'm not too happy with how long this 1.1 volt decoupling is, but again, we'll call it good enough for now. Realistically, we'd probably want, with almost 100%, we'd want more space, but less space. We want that to be closer. But again, you can get away with some pretty crazy things nowadays, and I think it will probably still work fine. I want to rotate this so that we can use this extra space here to route our QSPI. Just like that. We just need a little bit more space in this area so we can get all 4 of these traces out. So yeah, that is what we're going to do. And again, I'm just using the slide command here to clean things up as often as possible. And it looks like these traces are going to have to get nice and comfortable with each other. So otherwise, we won't be able to fit everything. Okay. And 2 more. 1 and we're out of room. Okay. So 2 options. One is we can take this QSPI and actually move it up here, which I am quite tempted to do because realistically all this is a pull-up resistor. It does not need to be close to the micro. And the other option doesn't really matter because I think that is the best option. So go ahead and delete those and move this component up here. Perfect. As I said before, your placement is usually pretty rough.
You always end up finding some things that you can do better, some things that just aren't working. And in this case, we were able to just move that Q-SPI resistor right next to the pin and not have to worry about finding all that extra space for our push neck mode here, not having to find all that extra space for our Q-SPI lines here. So should be able to just route these. If you're noticing that my loop removal isn't working, this is actually a known bug in the current release, so it's getting fixed. No need to worry. What is this? Line width, 7.87. Here we go. I had it in neck mode, so now we should be able to go back to constraint mode, and we are good to go again. So we're just roughly routing these really quick, and then we will take a second pass and use our slide command to just clean these up. Spread them out where possible. Perfect. Okay. So now these just have to connect to these different nets here. Let's see. This can do a little loop-de-loop around to here. Because I want this going to here. And this going to here. And this going to here. There we go. Now, just add those little segments in. Easier to slide at a 45-degree angle. We are good to go here. So this connects here. Make sure it's a straight line. All right, so those are pretty much all set. The Q-SPI lines at least. Let's go ahead and route, let's see, SDA and SCL, they need to connect here. These signals will probably have to go on the bottom layer just because we are getting a little constrained for space on the top layer. Let's see. So this D in, oh yeah, that's just a pull up, no problem. As you can see, I tend to be a little ADD. I move around from place to place when it comes to routing, but really as long as you have a system that works for you and you get through all of the routes sooner or later, it doesn't really matter what you tackle first. Obviously, if you're doing a high-speed design, then you might want to focus on the high-speed signals first, but in this case, everything is more or less low speed here, so we do not need to worry about that. Okay, let's see what we got left here. We have 55 connections. Okay, and some of those are just going to be, these power nets. So we do not need to worry about that so much. So this needs to connect to Q-SPI. We'll drop a via. Might as well get the rest of these fanned out while we can. Well, not sure what that's doing there. So SDA, drop a via, SCL, drop a via, and finally this net here, LED data. We got space for just one more via. Perfect. This is just a ground net. We can add a ground via. I do also like, let's see, where else do we have ground? Actually, I think if I remember correctly, on the RP2040, there are no ground pins on, you know, what is this, 1 through 44, or excuse me, 1 through 56. Yep, the only ground pin is the center pin here. So, okay, so let's route these on the bottom layer now. I'm just going to turn off my top layer and focus on the bottom. Turn off the place bound. Let's drop some vias first on the top layer here. So STA gets a via. SCL gets a via. Let's drop vias for as many signals as we can while we're at it. D7 gets a via. And then we're just going to copy that. Backlight, enable, read write, RS, ground, ground, ground. So these will need just a little thicker traces. And we can copy this as well. Paste, paste, paste. Power net. Nope. We want to connect to our decoupling capacitor. And then the decoupling capacitor will supply power from a via. Perfect. What else are we missing? Those all have vias. This needs a via for the backlight. This can just connect straight up. That's always nice. These can get vias here. And what else? We'll worry about the USB in a little bit. These guys can get, ooh, those are really long. These guys can get vias. And we'll do this in a second. This needs a via. Okay, now we can switch over to the bottom layer. Let's go ahead and I want to turn off the connections for these power nets, just so they're not in the way. Okay, so we have a couple signals here. LED 2 needs a via. There's a via. And just want to make sure that all these connections are showing via to via, except this here is USB, so we don't need to worry about that. And then we have ground here as well. So, okay, let's start connecting these. So these are our digital signals, or excuse me, our data signals for the SPI interface. So we can connect them one at a time. And it's nice that they are lining up for us so we don't have to do any pin swapping. Looks like we might have to move this maybe over here. Yeah, that seems fine. There we can just slide that. Okay. Should be plenty of space. Famous last words. We'll see if we have the space. Should be okay. Looks like it'll be okay. And it's okay. Perfect. All right. So this just needs to get connected up to this via here. All right. And next we can do these ST and SCL lines. These are pretty simple. Go up through here. By the way, you'll notice me kind of alternating between this left and up versus upward and left. The default hotkey is T, or if you right click, it's this flip 45-degree angle. super useful when you're trying to kind of get right at a pin and make sure that your traces stay nice and straight. Okay. And then this is what? This is SCL. Okay. And then we have this LED data, which looks like we can pretty easily just route without having to worry too much about running into any other signals. Perfect. Okay. Contrast needs to come all the way from over here. And again, this is just very, very slow. Doesn't really care about any noise type of analog voltage. So we don't have to worry about anything crazy. This trace needs to make its way over here. So we will make some room. We can always find more room. There we go. And now, move these up a little bit. We can do a little bit of zigzagging and get this trace right in through here. Awesome. Then we have this trace left for enable, this trace for read write, and this trace for the RS. And we're almost done. We are almost done. We got our properties, 23 connections left, 8 nets unconnected, and again, some of these are power nets. Awesome. Let's do the USB next. So I'm routing these not as a differential pair right now. Again, maybe in a follow-up video, we will treat these as a differential pair, but because these are very short traces, not that big of a deal, we will couple them nice and closely together. But realistically, this is going to be functioning at very, very slow speeds. We do not need to worry about these signals. There we go. We'll pretend that we will pretend that it is a differential pair. Switch over to bottom layer. Okay. And then we just need to crisscross these. So I'll need to drop a via. Go there. And then this can stay on the top layer en route to this pin. Perfect. All right, then we have these CC pins. These just connect directly to these resistors. You don't have to worry too much about having enough room for the power pins, as these are through-hole pins and we can just route them on one of our internal power layers right here, which actually they're already connected to the 5 volts. So realistically, yeah, we just need to connect some vias up to here and add a shape. So we'll do that in just a second. See if there's anything else here. Yes, so this ground, let's add a via there, and then we'll add a shape. Okay. This ground can connect directly to this pin. Perfect. So this pin 4, if I remember correctly, is actually an enable pin. Yeah, so this doesn't have to have a very fat connection to the pin itself. Alrighty. Let's just add a couple shapes here. So we'll go into our shape command, and in this case, I'm okay with just a rectangle, conductor top, and I want this to be on my 5-volt net, and we'll connect it like this. Now, because we're doing this, we get nice thermal connections, and we don't have to worry about, not having a good connection here. We can make this just a little bit bigger, maybe even all the way out here. And what I want to do is just drop a couple vias right around here, except these will be 5-volt vias. I'm not sure why these are still connecting to ground, but we can fix that really quick. Select multiples and set them to 5 volts. Perfect. So this way we have the 5-volt power from the USB just coming directly to this here. And then we can do the same thing with this shape, copy it, paste it right here so that it connects to our 3.3 volts. And same thing, we can drop a couple of these vias. You know what, let's just do them one at a time. So 1, 2, 3, 4, and let's set these vias to 3.3. Great. So now the 3.3 volt power will be going down into the power plane. We'll add a power plane here in a second. 5-volt power is just coming up through these vias into this capacitor to our voltage regulator. And then this voltage regulator is just connected directly down into the ground plane right here. So, all right, next thing we need to do is on this power plane, make sure that all of our power nets are connected together. So we have this 3.3 volt net and we have this 1 volt net. And let's just change the 1 volt into, let's say, oh, we're already using yellow. So let's use a blue. Okay. So what we're going to do is add a shape which is going to connect these 3 vias, and then add a shape which is going to connect all of these yellow vias together. And what that should do is basically ensure that we have good power connections with very, very low IR drop to all of our power pins. And yeah, let's just go ahead and start drawing them. We're going to be using the polygon tool this time, as we just want to make sure that I'm going to turn snapping off. Grid's on. Just got a slightly bigger grid. There we go. And in my fine filter, I want to select nothing and just start drawing a shape right on these. Well, we want to be on the power layer. There we go. Okay, why aren't we drawing? There we go. So snap, I actually want that on because I want to be able to snap to grid points. There we go. All right, so this shape is going to go up like this. Diagonal. And we want to exclude this 3.3 volt via here. So we'll give it a nice wide berth and just connect directly to this via right here. Now, the current of this net is probably comically low. So again, this is overkill, but good to get into the practice of doing this. Okay, so this shape needs to be increased in priority and is out of date. So we need to update all of our shapes. And we should be seeing some spacing between these shapes. So now we need to figure out why we're not seeing that. So this larger shape belongs to the 5 volt net.
This smaller shape belongs to the 1-volt net. Okay. It's unfrozen, unlocked, and this one, okay, so this one's locked and frozen. We unlock and unfreeze it. We should now be able to update our shapes, and there we go. Now we have some nice spacing between our shapes. And yeah, okay, I think this shape is good. Next thing we need to do is just draw a shape for our 3.3 volts. We are going to keep this one very, very rough because realistically it's just everything that you see in this area minus this 5-volt net stuff over here. So let's create a 3.3 volt on the power layer. And we're just going to start here. Okay, fine, we'll start here. Come on. We'll start out here. And that looks good. Again, we can use the backspace to remove a vertex. So normally I would want to finish it over here, but we have this little extra segment which we can get rid of, no problem. So now if we select our shape, so we just need to reduce the priority on this one. There we go. So once we've reduced the priority, these shapes are rendered in the correct order. And now all I'm trying to do is just hit boundary. There we go. I just like to have nice right angles where possible. There we go. And then this can come down all the way here. And we can pull this in. Wonderful. Okay. So now the 3.3 volts that's coming from, this regulator here is going to be supplied to all of these vias and all of the pins that need it. If I remember correctly, we'll look at the top layer. Yep, these are all vias. And this guy still needs a via, I just realized. Let's go ahead and add that. Perfect. There's our via. And let's go back to our properties. And now we can see, wow, just by adding that one shape, our unrouted nets and unrouted connections are both at 0. We have more or less finished routing. We might do a little bit of cleanup, but it is great to see. And yeah, feels good to be pretty close to done with this design. Looks like this shape may have gotten moved a little bit. Not sure how that happened. Let's go ahead and just delete it. We have another shape on the ground layer, which we can always just copy and then go to our power layer, paste special, just like that. On power layer conductor, there we go. And make sure that this is our 5-volt nut. These things do happen sometimes, so don't worry if you make little mistakes. The nice thing is that you can always fix them.
I did accidentally add a ground plane to the top, which isn't necessarily a bad thing. Probably could add one to the bottom as well. Yeah, might as well. Let's go ahead and do it. So paste special on the bottom plane conductor. Here we go. And most likely what I'll do is just add some voids here. Actually, I don't even know if we need them. So what we can do is we can select this shape, and if we go into properties, we can say that we want to suppress shapes less than, I'll say 200. See what that removes. So that removed this little sliver here, and really we don't have to remove anything else. So that looks good. These slivers are pretty small. Let's set the minimum web to 8 mils. And should remove these guys. Or maybe it's a little more than 8. Let's try 14. Let's try 20. There we go. So I'm pretty happy with that. I don't like to have these little slivers between the traces unless they're, fully connected. And in this case, they weren't, right? So this little area was happening here. Take a look at the top layer. I think we can probably do the same thing with the suppress shapes less than 200 and minimum web of 20. And that should remove most, if not all, of the unwanted little voids and areas in our shapes. Now, one other thing that we can use, and let's just go ahead and update our shapes. One other thing that we can use in the properties panel is we get this little shape island section here. And just by clicking X on the shape island, it removed the island that was in this area here. So normally you could stitch these together by adding a ground via, but in this case, I am not at all concerned. We could add some stitching vias throughout here, but for now, we will call this section of the video done. So we're done with the first pass of our routing. In a future video, we will do just a little bit of cleanup. Trying to think of what we might actually need to clean up, but for the most part, I am very, very happy with this routing. Hopefully you guys learned something in this video. Thank you again for watching. If you have any questions, comments, or concerns, please let us know, and we will make sure to answer any questions or comments in the comments for this video. And yeah, I will see you in the next video. Again, thank you for watching, and take care.